Today is Chapter 3, Section 5, and it's Systems of Linear Equations in Two Variables. Systems means we're graphing two or more lines, which means our answer is going to be the point of intersection. Where do those two lines cross? So sometimes two lines cross looking like this, and that means there's one solution, which would be a point, some x, some y. The point where those two things intersect. Sometimes it's no solution, and that means the lines are parallel. And sometimes, weirdly enough, we have infinitely many solutions because you're given two equations, but they end up graphing the exact same line. So it's one line on top of the other. So we're going to solve these systems using substitution or elimination. Here's our first example. We're going to solve this system using elimination, and I'm going to talk about why here in a second. If you want to go ahead and write those down. We have 3p plus 2q is equal to negative 2, and then 9p minus q is equal to negative 6. We're using elimination because I don't really have the letter p or the letter q totally isolated on either side of my equation. Right now, p and q are both on this side, and p and q are both on this side. So what I want to do is see if I can get either the number in front of p to be the same or the number in front of q to be the same. I see right now that the number in front of p is a 3. This one's a 9. It'd be really easy to take this equation, multiply it by 3, and change our p's to be 9s. So what I'm going to do is multiply this equation by 3 and write it underneath. So 3 times 3p gives me 9p. 3 times 2q gives me 6q. And then 3 times negative 2 gives me negative 6. When you eliminate, you either add the equations together or you subtract the equations from each other. But when you do this, either all the p's have to disappear or all the q's have to disappear. So think about it. If I were to add these together, I would end up with 9 plus 9 is 18p. And then negative q plus 6q gives me 5q. I still have p's, I still have q's. This didn't help me solve anything. So what happens if I subtract these equations from each other? Well, 9p's minus 9p's means I don't have any left. They're all gone. And then I'm taking negative q minus 6q. That gives me negative 7q. And then on this side, I'm taking negative 6 minus a negative 6. So think about it. Negative 6 minus a negative 6 means I'm really adding those together, which gives me 0. If I divide both sides by negative 7, then I get that q is equal to 0. I'm halfway done. I just need to figure out what p is because there's two variables. One's p, one's q, and we just figured out what q is. So now I want to take any of the equations, it doesn't matter which one. I'm just going to use the original 3p plus 2q equals negative 2. I know q is 0, so I'm going to take it and plug it in for q. This gives me 3p plus 2. Instead of writing q, I'm writing 0 equals negative 2. Now I'm going to solve for p. We get 3p plus 2 times 0 is 0 equals negative 2. That means we have 3p is equal to negative 2. When you divide both sides by 3, you get that p is equal to negative 2/3. So how you would write your answer is that's the point where these two lines intersect. If I was to graph this line and then graph this line, they would intersect at the point negative 2, 3, comma, 0. That's where those two lines would intersect. So that's our final answer. We just solved the system using elimination. With this system, we're going to solve it using substitution. The reason I've chosen substitution for this problem is because I have a variable totally by itself. D is totally by itself. So what that means is that all of this is equal to D, which means these two things can replace each other. Instead of writing D, I'm going to write 2 minus 6C. I'm substituting it in for D. I'm replacing. So we have 1/2, and then instead of writing D, you're writing 2 minus 6C. And then you just continue this equation, minus C equals 1. We're going to go ahead and distribute. 1/2 times 2 is 1. 1/2 times negative 6C is negative 3C. We still have minus C equals 1. When I combine my like terms, I get negative 4C. Still have that 1. Subtract 1 from both sides. Negative 4C equals 0. You divide both sides by negative 4. We get that C is equal to 0. Now I want to figure out what D is, because I don't know. I'm going to use this equation just because it looks easier. I like to use whatever equation looks the easiest. So D is equal to 2 minus 6C. Instead of writing C, we're going to write 0. So D equals 2 minus 6, and then instead of writing C, like I said, we're writing 0. 6 times 0 is 0, and 2 minus 0 is 2. So the point that these two lines, if I were to graph them, the point they intersect would be the point 0, 2. And that's how you do that problem. This try on your own is super tricky, but there are problems like this in your practice, and there's problems like this on your test. So I wanted to make sure we're really good at it, and I would really love for you to try it on your own. So here's your hint. It says let x equal that 1 over u, and let y equal 1 over v. So we're going to rewrite the system in terms of x and y, then you'll solve it. So I'm going to go ahead and rewrite this first system for you in terms of how they say in terms of x and y. So instead of this u, the u being on bottom, you're going to write 6x instead. And instead of the v being on bottom, you're going to write 2y. That's how you rewrite that equation. I want you to try to rewrite this equation and then solve using substitution or elimination. Try to practice one of those two. And then once you find x and you find y, you have to plug them back in to these equations to figure out what u and v is. You'll plug them back into these equations up here to figure out what u and v is, because look what our original variables are. They're u and v, and so that's what we have to figure out. Good luck. I know it's confusing. Just try your best.